Hello and welcome to the session. Now we will start one of the bit interesting topic called as maps in collection framework. So let's get started. Now map is basically an interface and it is altogether different from the normal collection framework. So we have seen it here. uh, that this is normal collection framework interfaces and classes, but map is something which is little different. So it does not follow normal structure in the earlier this kind of interfaces and classes. So let us see what is map and how it is different and what are the things involved in the map. So if you see, let's look at it, this data. So now we have certain employees in a company. If you see this side of the uh, uh, diagram, so we have sales employee, HR employee, marketing employee, and we have their details. Okay, if you see this car example, so we have some sort of a ID of a car, and now if you see the right hand side is basically little detailed information about the car. Now let's say if there's a delivery boy, so he has an item code, that he has to deliver some item, and these are the bit details of that particular item. So overall we can say that this left hand side is basically a key for that particular entity or data, and right hand side is basically the value. Now value can be multiple things, but it is a key value pair or key value structure. So this is basically the driving factor behind maps. So if you see any kind of a map, so we have a location and then we have the data of that location, longitude and other details. So let us see this map. So a map is something which maps or stores a key to a value. So it basically has a key and there is a value for that. Okay, so this is basically a map. Now both key and values should be object because we are using collection framework. Now a single key value pair is known as an entry. Okay, a key is to value is basically known as one entry in Hashmap or in map. Now it is useful while doing searching or updating elements based on the key. So we will see a practical example also, but just some theoretical points first. No first in first out concept, no indexing. So in maps basically there is no key concept, there is no indexing concept, there is no ordering concept. It is basically just key and value. Okay, there is a key and there is a value for that. Now it is not thread safe, and now if you see this hierarchy, so map is an interface and hash table, hash map are those classes who implements the map interface, and linked hash map again extends this, and some additional properties are there. And another branch is we have a sorted map, and that is implemented in the tree map. So let us see with an example what is a map. So if you see this in this example, I have this employee details. So this is how you actually create a hash map. The right hand side is a hash map and left hand side is basically a variable of the map interface. So we need to specify two things here for any kind of a map. What is the type of the key and what is the type of the value? Okay, because it's a key value pair. Now the left hand side will be basically what is the type of the key, and right hand side will be the type of value. Okay, so here if you see, the key is integer and value is of type string. Now how to add elements into the hash map or into the hash map is basically we have a put method. Now earlier collection framework there used to be add method. Here there is no add method, here there is just a put method. Now in the put method what we need to specify is basically key type and the value type. So I'm putting some key and value structure. We can go with this example also, but I have just used a very simple example here. There's a key and there is a value, employee ID and let's say employee name. Now this is how you get the size, like dot size. And now how to retrieve individual elements. So how to retrieve the individual elements is basically you need to provide the key and you will get the value. So employee dot get, and you need to provide the key. So if you provide the valid key, it will give you the valid output. If you do not provide the valid key, I mean the key does not exist, then it will not give you the proper value. I think it will give you null value. Okay, employee dot clear will basically wipe out all the key value pair and the size will be set to 0. But when you say size will be set to 0, that does not mean it will be assigned null. Okay, that is just that the size is 0. Now we will get the size. Let's run it one cycle and let's see what is the output. Okay, so first of all, the size is 5 because 5 elements are inserted. Now you get a particular value based on the key. So by value of 201, 201 is Ben, so that's why you get Ben. Now you provide invalid key, so you will get null value. Okay, because there is no set with that particular key, so there is no entry set with that particular key, so you will get a null value. Now again clear, and then if you get the size, so it will be size will be set to 0. Now similar to earlier examples also, if you see right hand side, this is a implementation of Hashmap or an object of Hashmap class. If you see, Hashmap is a class and in the util package. Now right hand side is basically an object of the class, and left hand side, if you see, a variable of the object, variable of the class, or left hand side you see the variable of an interface. So both things are fine. Whichever way you want to implement it, there are developers who are using this format or earlier format. Anything is fine. Now let us see the next example. Now in the next example, we are just seeing some additional methods. So there's a hash map for parcel, which is string is a key and string is a value. This is also correct. You can have a key as a string and value also as a string. Perfectly fine. So I'm just putting some uh, courier items for this parcel hash map, and now I'm getting the size here. So if you see here, null key is allowed. Okay, that is the advantage. You can have a key as set to null if the key type is string. Now this is allowed in the sense that sometimes the key is null, but practically there is very less application where you have key is set to null. Now when you say remove something, so it will remove the particular entry set. This key and value totally will be removed. Okay, then you see the size, it will be reduced by 1. Now another thing is, if you want to check whether the whatever are whatever keys are there, if a particular key is present or not. Okay, so laptop is present and I think book is absent. So if it contains, it will say true, otherwise it will say false. Now again, contains value, so contains a specific value. So if it contains, it's a true, otherwise it's false. Now how to iterate through the hash map? So as we discussed earlier, hash map does not maintain any index of the element, or also it does not maintain any order. So how do you iterate? So you iterate using for loop. Okay, so you get a size here. So entry set, you get all the entry set, so that you again take it into individual entry set, and you get individual key and individual value. Remember that this will not be in order. Why? Because the order is not maintained in the hash map. Okay, you can also print individual keys using key set, and you can get all the values using value set also. This is individual key and individual value. And if you want to iterate, you can use this normal iterator interface, which we have used traditionally for list, queue and map also. So here also we can go as a iteration using iterator. Okay, so let's run it and see what is the output. Right, so first of all, the size is 5, then you remove it, then the size is 4. The size is 4. Contains key, so first is true, second is false, first is true, second is false. Okay, then this is iteration, so iterating through the hash map. So these are the key, value, key and value. So 4 keys and 4 value. These are the this is the key set. So if you want to get all the key set, this is all the keys which are present, and these are all the values which are present, right? And the last one is using iterator, so you get again the key and value. So this is where you get the key and the value. So iteration using different techniques, that is also possible in Hashmap. So Hashmap is quite interesting, and the Hashmap is also widely used interface and class in collection framework. Now let us see another example. Now there are two hash map here. One is age and age2. So suppose if you want to check whether the hash map is empty, so you have an is empty method. So map interface has lot of methods, lot of useful methods for different operation. Now put if absent. So if a particular key is present, is absent, then only you put it, otherwise you don't put it. Okay, so that is basically put if absent. Remember, this is for key and not for value. There can be multiple keys having the same value, correct, but there can not be a duplication of the key. So put if absent works on the key itself and not on the value. Now put is there, put all. So put all is basically adding altogether another set of hash map into current hash map. So age 2 will be totally added into the age hash map, that is using put all. Okay, and of course there's a replace, so it is basically updating. So if the key with, if there is a hash map age, if it contains a key called baby, then the value of baby will be replaced by 2. Okay, if it is not, then it will not be replaced. Let's just run it. Okay, so similarly you will get this kind of output. Okay, so now that is all about hash map. Okay, so yeah, there's no FIFO concept, no indexing, that's it. Okay, so let us see the difference between key and value. So key is something which should be unique. Okay, key should always be unique. Value can be anything, can be duplicate, can be null, whatever. Okay, value is basically doesn't matter for any kind of a comparison or all. Everything is based on the key only. Now only one null key is allowed, multiple null duplicates, everything is allowed in value. Now keys are not ordered, values are also not ordered. Okay, all keys are stored as set and all values are stored as a set. So that is why if you see in this example, we were getting the entry set. Okay, we were getting the key set and value set. So this is basically set. Okay, all keys are stored as set, all values are stored as set. Order is not maintained, and here also order is not maintained. So in map basically order is not maintained. Now let us see other linked hash map and tree map. So linked hash map is same as hash map and it also maintains the insertion order. So linked hash map is slightly different. It maintains the insertion order. So the order in which you enter the elements, the in the same order you can retrieve it. Okay, and tree map is something different. So we will see first the linked hash map example. We will see the linked hash map example. So if you see the order in which I am adding the elements is basically, let's say 401 201 933 498 571. So the order is like this and it is a linked hash map. Okay, so let me just run it and let's see what is the output. Right, so if you see the order in which I have entered, the same order will be there for retrieval, whereas the same is not possible for hash map. For hash map the order is not maintained, so when you retrieve the hash map elements, it will be in some random fashion. Okay, tree map maintains the insertion order in ascending order. This is slightly different. Okay, hash map maintains insertion order but there is no ascending order or descending order. Tree map is basically maintains the insertion order and in ascending order. Also it does not allow null key. This is also important, does not allow any null key. Now let us see with an example, tree map example. So if you see in the tree map, so see here I am having the same statements here like 401 201 same thing, but in this case the insertion order was maintained, whereas there is no ascending descending thing. Okay, in the linked hash map, if you see there is no ascending descending key. Now same thing if I do for tree map object, let's see what happens. Okay, so if you see the ascending order is maintained. Okay, so insertion order is little different. If you see 400 is first, 201 is second, 933 is third, but if you see the when you retrieve, the key is basically in the ascending order, the keys are in the ascending order. Okay, the same mechanism for while loop and all. Okay, so single key value pair is known as entry. It is useful while doing search and all. Yeah, this is all the same. So yes, so this is about hash map, linked hash map and tree map. It is most popular collection class in the map hierarchy is basically hash map. It is very widely used, and it is very simple to understand. Now let's continue the remaining discussion in the subsequent topic. Thank you.